For modern luxury architecture, the ultimate goal is achieving complete, unbroken transparency. Designers want to create a perfect floor-to-ceiling horizon, where the building itself seems to vanish into the skyline. The problem is that glass is stubbornly physical. It is incredibly heavy, inherently fragile, and poorly suited for keeping heat inside a building. To solve these physical limitations, builders typically rely on thick metal grid frames. These heavy mullions and transoms provide the necessary structural support for thick triple-glazed panels and stop the interior climate from leaking into the environment. This creates a rigid standoff on every major project. You can have a pure, minimalist aesthetic, or you can have a structurally sound, energy-efficient building. The Schüco FWS 35 PD Panorama Design system was engineered to eliminate that choice entirely. The primary feature of the system is right there in the name. The exterior face width of the frame is exactly 35 millimeters. That is less than 1.5 inches of visible metal separating massive panes of glass. Despite having a profile the width of 2 fingers, this exact frame is rated to pass the most rigorous structural and environmental building codes in the world. Standard engineering logic suggests that a 35 millimeter profile would fail under the crushing weight and thermal demands of a modern skyscraper. The first barrier to ultra-thin profiles is gravity. Modern environmental glass is incredibly dense, and that weight has to be managed by the frame. This technical rendering details how the FWS 35 PD is engineered to accept heavy triple glazing, housing glass thicknesses of up to 50 millimeters within that minimal frame. Looking at the intersection here, you can see how the structural capacity is managed. The horizontal transom and vertical mullion distribute the load so effectively that the system can hold up to 400 kilograms of glass per transom. That extreme load-bearing capacity even allows architects to design cantilevered, all-glass corners, removing the need to install thick, obstructing corner pillars. The 35 millimeter exterior is deceptive. It hides a highly calculated structural spine engineered directly into the interior geometry. Once the glass is supported, the next challenge is temperature. Metal conducts heat, making the window frame the easiest path for a building's climate control to escape. To stop thermal transfer, Schueco developed highly insulated and super-insulated variants of the profile. Instead of relying on solid metal, the system uses a new isolator technology, utilizing an internal core foam to break the thermal bridge. The prefabricated pressure profile is then fitted with specialized internal sealing and a reflective foil. This barrier minimizes energy loss from thermal radiation by reflecting the energy back into the room. The system achieves a UFAF value of 0.88 and a UCW value of 0.79, meaning the rate of heat loss through the frame and glass is low. Those metrics earned the super-insulated variant an official Passive House certification from the Passive House Institute in Germany. By replacing solid metal with advanced material science, shrinking the frame actually increased its total insulation value. Beyond weight and temperature, a facade still has to act as a physical shield against severe weather and potential intrusion. This cross-section illustrates the system-specific continuous attachment grid. By locking the mullions and transoms directly to the building structure, the entire facade functions as a single rigid unit. Inside those hollow chambers, a built-in pressure-equalized ventilation system manages environmental pressure from wind and rain. That structural integrity also applies to security. The minimal frame is officially tested to meet RC2 and RC3 burglar resistance classes. Extreme slenderness does not equal vulnerability when the internal geometry is perfectly optimized. All of this internal physics works perfectly in a factory, but on the construction site, a complex system still has to be assembled by human hands. The profile uses a high number of identical parts across the entire facade. The Schüco FWS 35 PD removes the traditional standoff between the design concept and the physical reality. A building can now support 400 kilograms of glass per section, achieve passive house thermal efficiency, and repel RC3 level intrusions, all while maintaining a 35 millimeter sightline. In modern building design, less is more is a useful rule for the visual profile, but it should never apply to the performance beneath it.